Very good morning. In today's video lecture, we can see regarding general Bayesian estimation. Okay, I not explain any with example. I will just give the concept of general Bayesian estimation. Okay, if they are asking any question with this one, just do it. Okay, general Bayesian estimation. General Bayesian estimators. Bayesian estimator, anyway, in the previous class we have discussed the Bayesian estimator as well as the regarding the one of the example related to the Bayesian estimation also. Okay, we will proceed with this one. In MMSE estimator, normally minimize, that is E of theta minus theta cap square, where the expectation is with respect to P of x of theta. Okay, so I will write that one. Minimum mean square estimator, that is MMSE, minimum mean square estimator, MMSE estimator minimizes what? E of theta minus theta cap square. Okay, where the expectation is with respect to is with respect to P of x of theta, vector x of theta. Okay, so I will just denote E is nothing but theta minus theta cap. Denotes the, I will denote this as estimator error. Estimator error. Similarly, I will denote the cost as, let C of cost of an error E is nothing but theta minus theta cap square. That denotes the, then that is nothing but a cost. Then your minimum mean square estimator minimizes what? Expectation of the cost of error, that is C of E. Okay, that is the case of general Bayesian estimation, where I can write where C of E is termed or called, is termed as cost function. Otherwise we can call this as risk function, or I can call this as risk function. Okay, underline that word, risk function. So I will give you some of the examples of a cost function. Some examples of cost function are as shown in the below figure. I will draw that one. So this is the figure what I am drawing for the cost figure, cost function. Okay, this is the error. This thing I can write it as cost of that error, which is nothing but square. You will get the cost function like this. Okay. Sorry. Draw it smoothly. Mine is not so smooth. Okay. So this is something regarding the cost function. So I will write this figure as quadratic error or squared error, called as squared error. Okay. So some points, some important points that you have to take it down related to cost function. The first point is, if C of E is nothing but E square, small, I can call this small, cost function is quadratic. In that condition, cost function is quadratic, and base risk is just the mean square estimate, MSE, or mean square error. Base risk is just MSC. Okay, underline that one. One note. That is average cost, or E of expectation of cost of error is termed as base risk is termed as base risk and is denoted by capital R. Okay, that's the case. The second case, right? If the second point, if C of E, cost of error, is nothing but E square, then the cost function, I have written that on the slide. Okay. So in that case, that is correct. I have written already. I have written this thing. If C of E is nothing but E square, cost function is quadratic, and base risk is just MSE. Just MSE. Okay. I will draw one more figure. So in that case, we can see what is the what we call as the cost function. Okay. So this is something cost of E. Okay. So in this case, the cost of E must be modulus of E. That is absolute error. Absolute error. They call this as figure A. Call this as figure B. This is something like that, E only. Okay. So in this case, that is for the cost function as shown in the figure B, for the cost function in figure B, your cost of P is nothing but modulus of E. Okay, I will write another figure. Stand the figure. This is C of E. This is E. Okay, this is minus delta 2 plus delta. This point as I will take is 1. Okay, here the cost function called as figure, called as figure C. For the cost function in figure C, what I can write? In figure C, I can write C of E, that is the cost function, that is C of E is nothing but 0 for E less than delta and 1 for E greater than delta. Okay, so this is called a hit or miss. Hit or miss cost function, very important. Hit or miss cost function, underline that, hit or miss cost function, otherwise called as uniform cost function. Okay, so just write one more words. We note that the above cost function are symmetric in E given a cost function that cost function is nothing but base risk of cost is given by the script R that is given by expectation of cost of E, that is given by double integral C of theta minus theta cap P of x of theta dx d theta, which I can further write it as integral That integral I can make it into box. Integral of C of theta minus theta cap P of x of theta d theta into dx. Sorry, P of this I can change. Sorry, this I can change it as P of theta bar x d theta P of x into dx. P of x into dx. Okay. Since P of x is positive, the cost or the risk R is minimized by minimizing the inner integral. By minimizing the inner integral. Okay, that is given by g of theta cap. That is nothing but integral C of theta minus theta cap P of theta bar x d theta. Okay. For the absolute error, cost function is given by g of theta is nothing but integral minus infinity to infinity modulus of theta minus theta cap into P of theta bar x d theta. Okay. I can write it as, this is nothing but integral minus infinity to infinity theta cap minus theta of P of theta bar x d theta. Sorry, minus infinity to, I can call this as minus infinity to theta cap. Okay. Minus infinity to theta cap minus theta P of theta bar x d theta plus integral theta cap to plus infinity, that is theta minus theta cap P of theta bar x d theta. Okay. So differentiating with respect to theta cap, differentiating with respect to theta cap and equating to 0 gives you what? Integral minus infinity to theta cap P of theta bar x d theta, okay, minus integral theta cap to infinity P of theta bar x d theta, which is equal to 0. You just differentiate this one with respect to theta cap and just equate to 0. Okay, you will get this one. So it's okay. So that I can write it as integral minus infinity to theta cap p of theta by x d theta, which is nothing but integral theta cap to infinity p of theta by x d theta. Okay. So just this is the important equation for the general Bayesian estimator. Okay. So by definition, theta cap is the median of the posterior PDF. Or the point theta cap for which PR of theta less than or equal to theta cap bar x should be equal to 1 by 2. Okay. Okay. For the hit or for the hit or miss cos function but g of theta cap is nothing but integral minus infinity to theta cap minus delta 1 into p of theta bar x into d theta plus, you just verify that one. Okay, integral theta cap plus delta to infinity 1 into p of theta bar x into d theta. Okay, so since integral minus infinity to infinity p of theta bar x into d theta equal to 1, I can write g of theta cap is nothing but 1 minus integral theta cap minus delta theta cap plus delta p of theta bar x d theta. Okay, so this is minimized by maximizing, right? This is minimized by maximizing integral theta cap minus delta theta cap plus delta p of theta bar x d theta. Okay, for small delta, arbitrarily small, I can call this as arbitrarily small. Okay, this is maximized by choosing theta cap to correspond to the location of the theta cap to corresponds to the location of the maximum of of P of theta bar x. Okay. This estimate is therefore the mode. This are variable, the mode. In bracket I can get a location of the maximum. Location of the maximum of the posterior PDF. Of the PDF. It is termed as the maximum a posterior PDF. Maximum a posterior PDF. A posterior PDF or a posterior estimator, that is I call it as MAP. Maximum a posterior, underline that word, maximum a posterior estimator. It's very important. Maximum a posterior estimator. Okay. So just give a note also for that one. For the Gaussian posterior PDF, all 3 points are identical. All 3 points are identical. Just write for the Gaussian posterior PDF, all the 3 points are identical. Okay, this is something regarding the general Bayesian estimator, where we minimize the MMSE and ultimately we get the maximum a posterior estimator. Okay, thank you for watching this video. We can come across in the next video lecture regarding the linear Bayesian estimators. Thank you.